Hey guys, in this video we're going to be going over what I think has been a pretty tough concept for some students to grab, and that is the difference in velocity, speed, and acceleration at the 3 points of a projectile motion. And so what I mean by the 3 points is that a projectile motion that has symmetry, like this one shown here, can be considered to have points A, B, and C. And points A and C are here considered to be at the same height above the ground, and then point B is the peak height. And so this side of the projectile is when the ball is still moving up in the air, while this side of projectile is when the ball is now moving back down towards the earth. And then point B is the peak height, where the ball is no longer moving up from the earth or moving towards the earth, it's just at its peak height. And so let's go ahead, and I've drawn out some of the velocity stuff here for you. But you know what, let's go ahead and start with acceleration. The acceleration at all 3 points is the same, and that's because when you think acceleration, you want to think force as well. If you have an acceleration, that means you have some sort of net force, and if you have a net force, then you have some sort of acceleration. Now, if we were to draw a free body diagram for all 3 points would have the same free body diagram of a downward force of gravity, and that would be the only force acting on it, assuming that there is no air resistance. Because of that downward force, that net force, we would have an acceleration. The mass of the ball is equal throughout the entire projectile, and so the acceleration at all 3 points would be the same in the downward direction. And so that's what actually will account for the loss of speed and velocity moving upwards, and will result in the increase in speed and negative velocity going downwards. So acceleration, so all in all, acceleration is the same at all 3 points, and that is due to the acceleration of gravity, or the negative 10 meters per second squared. So now let's go ahead and discuss velocity. I've drawn up here that velocity on the left part of the symmetrical projectile is positive, while the velocity on the right side is negative. And that's because we are at point A still moving up, right? We're moving away from the earth, and we're assuming that up has a positive direction. And so when we start at the projectile, we start at 10 meters per second, and then as we move upward, we're losing velocity, but we'll eventually get to 0 meters per second. But all of it is positive because it's moving in the upward direction, right? So even though we're decreasing in velocity, we are still positive because it's moving away from the earth. Whereas on the opposite end, when we've passed that peak height at 0 meters per second, we're going to start moving downward, so negative 1 meters per second. Notice how it's increasing the numbers, like 1, 2, 3, 4, and then eventually 10. But since they're negative, we consider it to be a decreasing velocity because the numbers are getting smaller and smaller and moving towards the negative direction, and so we're technically decreasing the velocity. Okay, now this is where it gets a little tough conceptually, because velocity is different from speed. Speed has magnitude, and if you look up the definition of magnitude, will give you a simple definition, and that's size. Right, so when we think size, like let's think of people. Let's say I'm 5'7", but you can't describe somebody as being negative 5'7". Right, you can say that the ball has a positive 10 meters per second here, and then a negative 10 meters per second here, and that makes sense to us because we're relating it to its direction that it's moving. But speed has magnitude. Speed doesn't have any direction, so we measure speed by its size. And by its size, you can't say that somebody has negative 10 meters per second. So we wouldn't say, you can't say that somebody is negative 5'7". So we would say that they are still 5'7". And in the same way, you can't say that the ball at point A has 10 meters per second and at point C has negative 10 meters per second, because speed doesn't deal with negative values. Speed can only be positive. Right, so I'm going to demonstrate that here. So you've got the 10 meters per second that we started here, and then we're eventually going to get to 0 meters per second, and then moving in the downward direction, we're going to get to 10 meters per second. Again, not negative 10 meters per second, because again, we don't measure negative values in speed. Speed only has positive values. And so that means that here speed is decreasing, while here speed is increasing. And velocity differs because here the velocity was decreasing and the velocity was increasing here. All right, so hopefully that made sense. I drew this down here for you. So velocity has direction and it can be positive or negative, whereas speed does not have direction and can only be positive. So remember, speed can only be positive. So that would be the difference between the speed and the velocity. And so hopefully that made sense. We're going to do some practice problems, so hopefully we'll get it into our heads. I also recommend you check out other video forums. Definitely always want to check out 3 or 4 video forums if it's possible. And so now we've discussed velocity and speed. And then I just want to mention one more thing, and that's the velocity on the horizontal direction. That's this velocity here, Vx. Now if we're assuming that Vx, that moving towards the right is positive, then Vx, or that horizontal component of the speed, is always going to be positive and constant, right? Because unlike the vertical component of velocity that has gravity acting on it, the horizontal component here does not have any other force inhibiting or enhancing it. So at all points, that force is going to stay that velocity is going to stay constant. It's going to always be in the positive direction, if right is your positive direction, and it's always going to be constant. And even at point B, we still have that positive velocity in the horizontal direction, even though we don't have a vertical component of velocity at point B. So speed and velocity in the horizontal are constant and positive if they're moving to the right. If it was moving to the left and we considered the left to be negative, then our velocity would be considered negative, but our speed would still be considered positive, because again, speed cannot be negative. So now let's go ahead and try this practice problem here that we've got. And it asks, how does the speed of the ball at the 3 points on the figure shown above, how do they compare? And so we talked about speed. We said that the speeds at point A and point C, even though they're in opposite directions, they are both positive and they are both equal. So the speeds are equal. So we're looking for something we're looking for the answer that's going to tell us that the speeds of A and C are equal. And so that would not be A, that would not be C, and that would not, and so we can cross those out automatically because they don't say that A and C are equal components. The speed at point B, like we said, is 0 in the vertical direction. It does have some speed in the horizontal direction, but in the vertical direction, the speed is 0. And so because all of them have a positive component of velocity in the horizontal direction, we can pretty much ignore that in this problem, because what we're really comparing is the vertical components of velocity. And so at that point, Vy is equal to 0 meters per second. It's at the peak height. And so that would mean that the speed at point B is less than the speed at point A, which is equal to the speed at point C. So the answer is not going to be B, because that says that all speeds are equal. And then the answer is not going to be D, because that says that the speed at point B, or the peak height, is greater than the equal speeds of A and C. And so that leaves us with point E as our answer.